Hi, and welcome to a presentation about tornado vortex signatures. I'm going to be talking to how we look on radar to find tornadoes. Now, in class we talked about hook echoes. Hook echoes are the characteristic shape of a thunderstorm that contains a tornado in conventional radar. You can see a great example, possibly the best example I could find, of a hook echo. This is from the famous May 3rd, 1999 Moore, Oklahoma tornado, and you can see it has a great example of a hook echo in the southwest corner of the storm. However, most tornadoes don't have that perfect of a hook echo. Usually you can find one if you're looking very closely, but the hook is often somewhat misshaped or too small or hard to see because the storm is so far away from the radar station. A better way to detect a hook echo, to detect a tornado in a thunderstorm is using Doppler radar to detect what's known as the tornado vortex signature. Now, we haven't talked much about Doppler radar in this class, but Doppler radar doesn't just detect the presence of the raindrops, it can detect part of the motion of the raindrops in the cloud. Now, it isn't the same thing as detecting exactly how every raindrop is moving, but it could overall tell whether the drops are moving towards the radar dish or moving away from the radar dish. By tracking the raindrops in a thunderstorm, we're able to find indications of rotation. Our tornado vortex signature will be exactly that. It will be an indication of rotation that can only be seen on Doppler radar. And the way you're going to be able to tell that there's rotation going on is there's going to be strong inbound velocities right next to strong outbound velocities. By inbound I mean they're heading towards the radar dish. By outbound I mean they're heading away from the radar dish. You can imagine, for example, suppose we have some radar station down here in the corner of the screen. If it looks out in some direction and it sees raindrops that are heading away from the radar station, outbound raindrops, right next to an area of inbound raindrops, this could be intended as the Doppler radar signature of a rotation. And if it's a strong enough rotation, we could call it a tornado vortex signature or a TVS. So that's what we're going to be looking for when we look for the tornado vortex on a Doppler radar. And I want to show you some plots from June 9th, 2005. Now, this was the day of a major tornado outbreak across the central United States. There were 40-some confirmed tornadoes this day. And on this visible satellite picture, you can see across Kansas and Nebraska that there's a huge complex of thunderstorms. These are very high. You can see the anvils of all these thunderstorms casting shadows onto the ground. You can tell this is a late afternoon picture because the shadows are being cast out to the east. And there's in blue there indicated a tornado watch for much of western Kansas and southwestern Nebraska. And even at this time, there were a number of tornado warnings and severe thunderstorm warnings. We're going to wonder, how did they find those tornado warnings? What was going on? What did they see on radar that made them think they needed to declare a tornado warning? Here's the conventional radar out of the radar station at Grand Island, Hastings. I think the radar dish is actually slightly south of Hastings, Nebraska. And this is conventional radar. All we're seeing is the precipitation, and you can see that there are a number of very large supercell thunderstorms going on at this time. We're going to focus particular on two of them. The one in southwestern Nebraska, that's actually Furnace County, just to the east of McCook. And the one in northern Kansas there, that is Rooks County. It is just to the east of Hill City, Kansas. We're going to focus on those two particular storms because they were well observed by the radar in Hastings. Now, this is the Doppler radar presentation of what was being seen at that same time out of Hastings. Now remember, Doppler radar is not seeing precipitation, it's seeing the velocity of the precipitation. And in this particular presentation, oranges and reds mean heading away from Hastings, and blues and greens mean headed towards Hastings. They're inbound velocities. So oranges and reds are outbound velocities. But you need to keep track then of where Hastings is on this map so you can figure out what is inbound and what is outbound. And we're going to focus first on Rooks County in Kansas, and we're going to look at how that supercell thunderstorm is depicted in the Doppler radar presentation. I'm going to zoom way in on to Rooks County there, just way down there in the bottom left corner of your screen. And we can see Hastings up near the top of your screen, so we know when we say inbound we mean headed towards Hastings. When we say outbound we mean headed away from Hastings. At this time we can see that there is a large area of very strong outbound velocities in Rooks County. These are raindrops that are headed at maybe 40-50 meters a second away from Hastings. At the same time, right next to it, there is an area of very strong inbound velocities. These raindrops are headed towards Hastings, maybe 35-40 meters per second, something like that. Right next to each other then we have adjacent areas of strong shear. There is strong indication of rotation. This is our tornado vortex. It is very reasonable to say that there's probably strong rotation going on in this supercell thunderstorm, and as a consequence, the National Weather Service office in Hastings, Nebraska, issued a tornado warning for Rooks County in northern Kansas. And in fact, that's exactly what this says. This is the actual text of the warning that was issued. It tells us that at 5:43 Central Daylight Time, the National Weather Service office in Hastings issued a tornado warning for Rooks County in north central Kansas until 6:45. Wow, that was over an hour-long tornado warning. Well, they were pretty sure that there was a big storm. It says here that at 5:39, several tornadoes were reported in Rooks County. The largest tornado was going to be seen near Stockton and Woodston. I don't know where those places are. This is an extremely dangerous situation. A tornado has been sighted. People in Rooks County should take shelter immediately in a basement or in a small interior room. Always good advice in a tornado. It also advises them that there is a tornado watch continuing until 11 o'clock. So Hastings did the right thing here. They saw the tornado vortex signature and they issued a tornado warning for Rooks County. If we go back to the broader depiction here in the radar, the Doppler radar, we're going to look then to see, okay, we got a tornado warning out for Rooks County. What else should Hastings be looking at? And I'm going to say that we should focus again on Furnace County in southern Nebraska. Remember, there was another supercell thunderstorm right there. And if we zoom in on to that area, you can see Furnace County is kind of down in your lower left corner of the screen. Hastings is kind of on the center right. So you know which way is inbound and which way is outbound. And if we look at the velocities, in the northern part of Furnace County, we have very strong outbound velocities. Those raindrops are headed away from Hastings. Right next to them, just to the south of them, a few miles to the south, we have strong inbound velocities, colored in those blue colors. Again, the people in Hastings should have looked at that and said, that looks like a indication of rotation. That is a tornado vortex signature. We should call a tornado warning then for Furnace County, which is exactly what they did. And so now at this time we have the two tornado warnings that were active in Kansas and Nebraska at that time. We can see that both were supported by Doppler radar. They both indicated a tornado vortex signature, or a TVS. So just in summary, tornado vortex signatures are another way to find tornadoes on radar. In neither of these cases were there great hook echoes on the conventional radar, but in Doppler radar, we were able to see a tornado vortex signature. The tornado vortex signature is an indication of strong inbound and strong outbound velocities right adjacent to each other, within a few miles of each other. That's going to be strong indication of a tornadic rotation. Now, we're not probably seeing the tornado itself. This is still bigger than a tornado. We're seeing rotation in the thunderstorm.